that when we're dealing with the properties of logarithms, this guy's a minus, but if we take a look at the first three, where property number 1 says that the log base A of m times n multiplication is log base A of m plus log base A of n, and 2, log base A of m to the r is r log base A of m, and then 3, we have log base A of a quotient is log base A of m subtract log base A of n. So what I really want you to notice is that since yesterday we went from here to here, today we're going to go backwards. If I were to look at going backwards, the property, the coefficients of the logarithms here and here are 1 in the formula. So that says I can't bring these two guys back together unless the coefficient on the logarithm is 1. I can't bring these two back together unless the coefficient of the logarithm is 1. The only time the coefficient of the logarithm isn't 1 is in this property, and that means that in order to move it back, you're going to have to bring the exponent up. When you bring the exponent up, then the coefficient of the logarithm is 1. So as I look at this problem right here, I notice that the coefficient of the logarithm here and here isn't 1. So I can't bring these back together under the subtraction rule, which is this rule right here. So I can't bring them back together under the subtraction rule unless the coefficients are 1. So what I'm going to have to do is I'm going to have to use the third property to bring or second property, this property, to bring the exponents back up. So this becomes then log base 3 of x to the 4th subtract log base 3 of x plus 3. That's the whole argument, and that's to the 1/2 power. Now you notice at the coefficients of the logarithm is 1. So now you can use property 3, which says if I have a difference, that it becomes a quotient or a division. Now, in order for me not to make a mistake, which I can easily, is I set myself up, and I can either use parentheses or brackets, it doesn't matter, because this thing comes back, and I'm bringing it back as a single logarithm. And the logarithm is going to be a quotient, x to 4th over x plus 3 to the 1/2. Now you can write that as the square root of x plus 3 if you want, or just leave it that way.
Can we put the x plus 3 under the radical?
Yes. So what he's saying is that can I write this as log base 3 of x to the 4th over x plus 3 to the 1/2 is really the square root of x plus 3. The answer is yes. That's an alternative way of writing that. That's just fine. I could have also used parentheses instead of square brackets. But what the brackets do, and I didn't see it so much in this class as I did see it in the other class, is that I see people all the time that say if I have, in this particular instance, I could say log base 2 of x to the 4th minus log base 2 of y squared. And what they would do is say, oh, a subtraction turns into a division, so then I write it this way, log base 2 of x to the 4th divided by log base 2 of y squared, because in their mind it says a subtraction turns into a division, and then you divide the two logs. Well, that is an error that can be so easily made, especially when we hit what we're going to be doing called the change of base formula in 10.6. which is why when I write this, I'm going to bring it into a single log, and that's why you see me do that. Because at which point, I'm going to make it one logarithm, and one logarithm has something. What does it have? It has the quotient of the two arguments. So this sets me up so I don't do this. So here we are. We look at the coefficients on the logs, and they're 1. It's a subtraction, and we know a subtraction turns into a division. So this is log base 2 of a division, which the numerator is 3x plus 7, and the denominator is x. And that's as good as it gets. Now here I notice this coefficient of that logarithm is 1, this one is not. So I'm going to have to bring the exponent up first. So this is log base 7 of x to the 1/3 power plus log base 7 of y. That's property 2. Now I have a product, a sum, and a sum, according to the property of logarithms, turns into a product of the two arguments. So I set up for it by knowing it's log base 7. I'm going to write it as a single log. And because that's a plus, this is now a product of the two arguments. Now again, you could write that, if you wanted to, as log base 7 of just the cube root of x times y. Y is to the 1 power, so you can't bring it under the cube root. But personally, I'd probably stop here while I was ahead, so I wouldn't make another mistake. But like this little thing accidentally coming over top of the y. But yeah, either way would be fine.